Hey there, MSM3. We are in Unit 3, Lesson 4, Solving Equations with Fractions. Now, there are several ways to go about doing this. So first, let me just look at one. One way to go about doing this is to recognize that this equation has a fraction that's being multiplied by the variable. And anytime you see something 4 divided by 5, where you've got this fraction bar and you can see that it clearly has divided by 5, we could multiply both sides by 5. That would give us 5 times 8, which is 40, equals 4x. And then we could divide both sides by 4 and get 10 equals x. Not too hard, right? There is another way that we can do it in one step. So that's what we're talking about today. To solve an equation above, you should have divided both sides by 4/5. Oh, geez, there's another one. So 8 equals 4/5 x. Do you notice how this is also read as multiplication, 4/5 times x? So I could divide this side by 4/5 and divide this side by 4/5. But what really happens when you divide by a fraction? You end up having to change it from division to multiplying by the reciprocal. And so instead of thinking of it as division, we're going to think of it as multiplying both sides by the reciprocal. All right? So you can multiply both sides by the reciprocal of 4/5. Two numbers are reciprocal if their product is 1. So for example, 4 times 5 multiplied by 5 times 4 comes out to 20 over 20, or 1 whole. So the reciprocal of 4/5 is 5/4. So when I look at this problem, instead of seeing a two-step problem, instead of seeing, oh, I need to divide, I see this as multiplying the right side by the reciprocal and multiplying the left side by the reciprocal. Now, in order to multiply two fractions, remember that they both need to look like fractions. So instead of thinking of it as 8, I'm going to think of it as 8 over 1. 4 and 8 have 4 in common. 4 divided by 4 is 1. 8 divided by 4 is 2. I would also be able to say the 4/5 times the 5/4 is going to cancel. And 5 times 2 is 10. 10 equals x, or x equals 10 is my solution. And that makes it only a one-step equation. So let's say you had something like 3/4 x equals 16 over 7. I don't know, just made that one up. The side with the variable has multiplication 3/4 x. I'm going to multiply the left side by the reciprocal 4/3. I'm going to multiply the right side by the reciprocal 4/3. Now, it's a little messy. It's not very friendly because I just made it up. There's nothing to simplify. The 7 doesn't simplify with either of things on the top, and the same with the 3. So across the numerator, I would do 16 times 4, which is 64, and on the bottom 7 times 3, which is 21, and I would let you leave it as x equals 64 over 21 because there's nothing to simplify. So multiplying both sides by the reciprocal is the fastest way to solve an equation with a fraction abutting the variable. So here's a few for us to work on. The first one here now is a two-step equation. So I've got to do any adding or subtracting first. So I'm going to subtract 1/8 from the left, subtract 1/8 from the right. I have 1/2 x equals 4/8. You can leave it as 4/8 or you can simplify it. It actually doesn't help you all that much to get a common denominator, because now you're going to multiply by the reciprocal, 2 over 1, 2 over 1, and you can simplify on the right. 8 divided by 2, 2 divided by 2. I'm going to get x equals 4 over 4, which is 1 whole. All right, how about this one? You have minus a half. So the inverse of subtracting half is going to be to add half to both sides. So negative 2/3 y equals. So 4 plus a half, we all know, is 4.5. But I'm going to need it to look like a fraction here in order to be able to do the next step. So I'm going to write it as 9/2. So I'm going to multiply by the reciprocal, 3 over 2, and it still has to be a negative. Negative times a negative is a positive. And I'm going to multiply by negative 3 over 2. And does it look terribly friendly? No, not really. Doesn't happen to be anything that can simplify. 9 times negative 3 is negative 27. 2 times 2 is 4. And that answer is acceptable just the way it is because it's in lowest terms. So this one has 3x over 5 equals 10. A lot of people will see this and say, I'm going to multiply both sides by 5. If you can look at this as 3/5 x equals 10, you might notice that you can solve it with a reciprocal. So times 5 over 3 times 5 over 3. We're going to treat the 10 as a fraction. We're going to treat it as 10 over 1. This would cancel on the left. X equals 10 times 5 is 50. 3 times 1 is 3. And nothing to simplify. Now, let's just say on this one I didn't notice that, and I did times 5 on the left times 5 on the right. 3x equals 50. I would divide both sides by 3. X equals 50 over 3. It would take me a similar amount of work, and I would still get a correct answer. Last but not least, you'll notice that this one has uncommon denominators. So you don't actually have to have all of them with the same denominator. You can, if that makes you happy. You can turn them all into 12ths. But the first step is to get rid of this 1/6. So I would subtract 1/6 on the left, subtract 1/6 on the right. I'd have negative 3/4 x equals, and then over here on the side, I would get that common denominator and say, how do I do 11/12 take away 1/6? 11/12 take away, if I multiply them both by 2, I get 2/12. 11/12 take away 2/12 is going to be 9/12. And now I'm back to fractions. I'm going to multiply both sides by the reciprocal, negative 4 over 3. Negative times a negative is a positive, times negative 4 over 3. And I got a bunch of simplifying I can do here. 3 divided by 3 is 1. 9 divided by 3 is 3. 4 divided by 4 is 1. Don't forget the negative. 12 divided by 4 is 3. And now, I've got 3 over 3. Don't forget the negative. So negative 3 over 3, or just negative 1. So lots of different ways to go about this. If you had wanted to get them all with a common denominator at the very, very beginning, you would have still gotten the same answer. And then there's just a list of reminders at the bottom about the order. Your goal is to isolate the variable. You need to make sure whatever you do to one side, you do to the other. You use the reverse order of operations. So we get rid of any adding and subtracting first if it's there. You can use reciprocals instead of the extra steps that include dividing. And you must show all of your work. Questions in class?